Funding for this series is made possible in part by the Donna J. and Charles T. Cole Charitable Foundation and by the Department of Geological Sciences at Central Washington University.
Hi, I'm Nick, and I love Washington's geology. I've been teaching it for 20 years now. Let's hit the highways, visit places you all know, and I can help you see Washington like you've never seen Washington before. Welcome to Central Rocks, Roadside Geology. Hey everybody, welcome to Thorp, Washington. Yakima River behind me, State Route 10, the old Sunset Highway between Seattle and Spokane, and some white rock. In fact, more than one white rock layer, right? A whole series of white rock layers, white bluffs. The locals refer to this as the white sandstone out by Thorp. We want to make sure, as geologists, that that really is sandstone. And if we're devoting a whole program to this, I suppose the answer is no. We want to bust the myth. Is there really sandstone up by Thorp? There's not. But to actually figure out why this is not sandstone, let's actually go to a sandstone that is well exposed in the walls of Kittitas Valley. Let's go up to Menashtash Ridge and learn our fundamentals up there before we tackle this. Let's head up there. Well, here we are up on Menashtash Ridge, just south of Ellensburg. It's the first ridge south of town, and we have some beautiful sandstone, high quality sandstone. Nobody's arguing that this is a sandstone right here. Why? Well, first off, I think the eye is drawn to the sand grains organized by layers. We can see coming through all of this sandstone, we have a nice horizontal set of thinly bedded sand. And if you look more carefully, there's actually a secondary set of layers that are an angle to that. So we actually have two different sets of layers throughout this sandstone. This is not just on the surface, this is throughout the sandstone itself. I've been teaching kids up here for 20 years, and there's been continual erosion off the front of this sandstone, and these layers don't go away. So it's definitely not just a surface thing. Let's get down to the level where we can see individual sand grains. Look at how uniform these sand grains are. How uniform in size they are. As I look at them carefully, and if I got a hand lens on them, every sand grain has a degree of roundedness to it, indicated that they've been transported. And the thing I want you to notice is that we don't have big pebbles. We don't have fine clays. Instead, it's a clean sandstone, meaning that every sand grain is about the same size and the same shape. That's what you need for a sandstone, and that's not what we're going to find back over at Thorp. Okay, we're back at the White Bluffs at Thorp. We're still not sure if we've got sandstone here, but let's make just a crude inventory of what we've got in this exposure behind me. Starting at road level, we've got some layered, pebble-rich stuff. Let's call that a pebbly layered unit. How about that? If we go up above that, we lose the layers, we lose most of the pebbles. We kind of have this fat, massive unit. That's the stuff that the locals think is sandstone. Let's continue above that. We're not sure about it yet. Let's continue up. My goodness, an enormous pink ball with some white to gray, big angular chunks inside of it. Okay, let's take mental note of that. Let's continue up. On top, draped over the top of the pink ball, beautiful layering again with some rounded pebbles. Up we go further. Another massive unit, meaning no layers and very few rocks. Above it, another pebble-rich unit at the base of that cliff, and then finally, making up the high cliff another massive unit with very few rocks inside of it. We have an alternating pattern here of pebble-rich layered stuff and these massive units. We're unsure about the massive units, but the pebble-rich layered stuff I hope is clear to you. River deposition. Okay, it's time to make a decision. We've seen what a good sandstone looks like up on Menashtash Ridge. We're back to this stuff at Thorp. Sandstone, thumbs up or thumbs down? I'm going to try to convince you, sandstone, thumbs down. This is not a sandstone. What evidence do I have? We don't have sand grains layered like we did at our last stop. Second of all, we have more than sand-sized particles. We've got rocks that I can pull right out of this unit. Here's a nice rhyolite pebble. Here's a nice andesite pebble. There's even places where I can pull out rocks that are super fragile. And this is one of the best pieces of evidence I have for you. These guys are pumice, volcanic pumice, that are fragile enough to crush in my fingertips. Now you tell me how grains of pumice can survive on a beach or a desert floor with a sandstone. We've got a lot of pumice in here, a lot of fragile volcanic pumice. This is not a sandstone. This is a volcanic mud flow, or a lahar, which is a slurry of water, ash, pumice, rock, anything else the volcanic mud flow pulls along as it comes away from an erupting volcano.
Well, wait a minute. An erupting volcano? Our sandstone is actually a deposit from a volcano? Yes. We have studied the volcanic mud flows from the 1980 Mount St. Helens eruption, and those deposits look just like these deposits here by Thorp. So, was it Mount St. Helens that made these layers, or Mount Rainier, or Mount Adams? Nope. Those familiar mountains have been standing for less than 2 million years. And these Thorp Lahars are 10 million years old. That means we have deposits here that have long outlived their source. Careful research by field geologists have concluded that the old cone-shaped volcano that erupted 10 million years ago to make these deposits once stood between Yakima and White Pass. And our Lahars flowed down river valleys that once connected that area with Thorp, a river system destroyed long ago by the rise of Menashtash Ridge.
Just in case you're still skeptical, more evidence that this is a deposit that happened quickly, a volcanic mud flow or a lahar creating this massive unit. Check out that white rock. That white rock had no time to settle to the bottom of the lahar. They're sitting in suspension. There was no time for them to settle out. I think that pink rock surfed in here on top of the volcanic mud flow. The volcanic mud flow probably traveled 30 miles an hour, coming down a river valley, and that pink chunk, that pink ball with the white chunks, is a piece of the volcano itself that rafted right in on top of that particular volcanic mud flow. This is way more interesting than a sandstone. This is way more interesting than a quiet collection of sand grains. This has power and drama. A volcanic mud flow coming out of the Cascades.
Funding for this series is made possible in part by the Donna J. and Charles T. Cole Charitable Foundation and by the Department of Geological Sciences at Central Washington University.